Okay, in our time together today, we are going to talk about our unit, Composing and Decomposing 2D Figures. This unit has three supporting standards, 1,6F, G, and H. Now, in this one, it ties closely to the unit that we just finished up, so we are connecting the learning from our prior unit to this current unit. So let's talk about each of these standards. So our first TEK in this unit is 1,6F, and the verb is compose. Again, this is a student verb, not the teacher verb. So the students are asked to compose 2D figures. How? Well, it says they're joining 2, 3, or 4 figures to produce a target shape in more than one way if possible. So there's a lot of important things here. 2, 3, or 4 figures to make a target shape. That means I'm telling them what shape I want them to make. I'm not just asking them to make something up. I'm saying use 3 figures to create a hexagon. I'm being specific. So I'm giving them a target shape, and really critical, more than one way. So we have to extend that learning. It says more than one way if possible. So we in this standard have some support from prior units. So 1,6C that we just finished with and K6F will support that. So in both of these, this is where the students are creating 2D figures. So in our prior unit, we created 2D figures. Now students are being specific about how they're going to create them. And then they did the same thing in kindergarten with K6F. So let's look at what that looks like. So if I ask students, here's a rhombus, use some pattern blocks to create this rhombus using 2 figures. Well, the only way students are going to figure out how to do that is to be allowed to explore with that. I can't just tell them how to do it. I need them to have a basket of pattern blocks and try different things. So they might try a square and see, oh, that doesn't work. Then they might try a triangle and see, oh, well, that works on part of it, but I haven't made the shape yet. But if I put another triangle, I've made the shape. So now I'm able to say, here's a good sentence stem for you. I made a rhombus using blank, 2 triangles. I made a blank rhombus using blank, 2 triangles. So we're allowing students to then write and explain what they've done, what they've created. And here's the in more than one way if possible. So let's say I give you a hexagon and I ask you to build this using 2 figures. Okay, well, we know how to do that because we're adults and we've played with this. Students don't know how to, so they need an opportunity to play. Well, here's where the more than one way if possible comes in. Now I've made it using 3 figures. Still have a hexagon. Notice I'm laying the figures on top of the target shape so I can see it's the same size. This is building a foundation for equivalence. So this hexagon is equal to this hexagon. They're the same size. Now, why does this not fit our standard? Even though I have created or composed a 2D figure, why does it not fit our standard? Well, our standard says 2, 3, or 4 figures. This took 6, so that does not fit our standard. But this fits our standard. It didn't say I had to use the same figure. It just said 2, 3, or 4 figures, right? This fits our standard. Right? I've created the target shape of a hexagon. I've used 3 figures. I've done it in more than one way. I've done it in several ways. So I've allowed kids to explore, to figure out what can I do to compose this 2D figure. So lots of exploration, lots of opportunities to try. So you want students to understand that these two figures have the same size. They're the same shape. They're equal, even though they didn't use the same polygons to make it. So you could ask the students, do you think that the yellow hexagon and this hexagon that you made are equal or are the same size? Or you could say, do you think that the yellow hexagon and the two trapezoids are the same size? And see what their understanding is. Then you could have them prove it to you. If they say yes, they could prove it to you by stacking it right on top and showing you that this is the same size. These two figures are the exact same size. Okay, let's look at 1.6g. So this is another supporting, and this one has two verbs in it. So our first requirement is for students to partition two-dimensional figures such as circles and rectangles. Did it say we're limited to that? It didn't, but it did say such as, so that's a great place to start. And I need to remember that a rectangle has a special friend. That's a square. A square is a rectangle. And this says into 2 and 4 fair shares or equal parts, 2 or 4. Do we do 3? Nope. Do we do 6? Nope. 2 or 4 equal parts. Here comes the other verb. Here was partition. Then we have to describe the parts. And we're required to use the words half, or like half of, halves, like 2 halves, fourths, and quarters. So that's a lot in a supporting standard. So this is setting up the foundational understanding for students of fair shares and equal parts. There is no kindergarten supporting standard for this. That's important for you to know. There is no kinder standard for partitioning into equal parts. So that's really important because you're building the foundation for it. So we need students to focus on the size of the parts that they've divided things into or partitioned things into, because we're developing the understanding of equal parts, fair shares. So, for example, if a student had a square and they partitioned it vertically, it creates 2 halves. Those 2 halves are equal. If they partitioned it horizontally, they've created 2 halves. Those 2 halves are equal as long as they partition it down the middle. If they partition it diagonally, they've created 2 parts that are equal. So we know we've created equal parts. So we want to do that in more than one way. We don't just want to do it one way and call it done. So for example, for my square, I want students to partition horizontally. I want students to partition vertically. And I want students to partition diagonally. And I need them to understand that these 2 parts are equal because that's half. I fold it, if I use paper, I can fold it in half, and I can see that those are done cut into 2 equal parts, or folded into 2 equal parts. These 2 parts are equal, these 2 parts are equal. They need to experience this with more than just drawing it. They need to fold paper. You can do this with Play-Doh, where they cut the Play-Doh with a popsicle stick. You can do this with geoboards, where they're able to take the rubber band and build a square and then show where they would cut it in half and see that the 2 sizes are the same. So we're going to remember that students can describe this as 1 of 2 equal parts, 1 of 2 fair shares, or 1 half, or halves. If we're talking about both of them, it would be 2 halves. Okay. A great activity with the Play-Doh is you take a circle, and so you can cut the circle with the cup or the lid of the Play-Doh, and then they cut it into halves and then cut it into fourths, and ask the students what's happening to the size of the parts from when you cut it in half and then you cut it in fourth. What happened to the size of the parts? Do they believe the parts are equal? If I shared these, does everyone get a fair share? Do the same thing with a square. ask them, can you partition this into 2 equal parts in more than one way? And then repeat that with fourths. All right, and then last we have 1/6H. This is our identify. This is a non-negotiable standard for the district. Identify. This is non-negotiable. Oh, it's not even on the screen. Hold on, let me slide this over. This is a super important one because what are we identifying? Examples and non-examples of halves and fourths. That's some really important foundational understanding. And again, this is another one of those that there is no Kinder supporting standard for this. None. No Kinder support. They don't introduce this at all. I'm going to slide that again. So, something that we hear kids say that we need to make sure we are not passing by, this little misconception, when you hear kids say they're unequal halves or they're unequal fourths. There's no such thing. Half means 2 equal parts. So you can't have unequal halves. You can have 2 parts that are unequal, but you can't have 2 halves. So if I draw a circle and I cut it like this, I've just created 2 parts. They're not equal parts. I can't say they're unequal halves because they're not halves to start with. Okay, so we have to teach kids here that parts must be equal in order to represent a fraction. And remember that through concrete things, we're able to build the foundation that they need so that they can start learning that foundational understanding of what fractions are, and then this builds on how they will compare fractions later. So this is another great one to use Play-Doh so that they can show examples and non-examples of halves and fourths. So if we create this, we would say this is a non-example of halves. And I would ask kids why. Because the 2 parts are not equal. They can only be halves if the 2 parts are equal. Okay, let us know if you have questions.